Okay, folks, time for a new section. This is section 3.3. This is going to discuss the product and quotient rules. And I want to start this video with a common mistake. Now, it's always dangerous to talk about mistakes because talking about them might cause you to remember them and then make them. So I want to make very clear what I'm about to write down is incorrect. So the common mistake is this. Sometimes students will see two functions multiplied together, and they'll be asked, what is the derivative of this resulting function that you get by multiplying them? And some students will say, well, I can take the derivative of f, and I can take the derivative of g, so why don't I just do that, and then multiply those together? This is how it works with limits, right? If the limit of a product, as long as the limits of the individual functions exist, you can take their limits and multiply them together. And, derivatives are based on limits, so why wouldn't it work for derivatives as well? But it doesn't. It turns out this is not equal. So let's look at an example first to demonstrate why, or not why, but that they are not equal. Let's take y equals x to the power 5. We know x to the power 5 is x squared times x cubed, right? Yeah, like 2 plus 3 is 5. Okay. If we take the derivative of x squared, we get 2x using the power rule. We're good with that. If we take the derivative of x cubed, we get 3x squared using the power rule. We're good with that. So then, taking these and putting them back together again, we would get 2x, the derivative of x squared is 2x times the derivative of x cubed is 3x squared, and that gives us, let's see, 2 times 3 is 6, x times x squared would be x cubed. There we go, 6x cubed. However, the derivative of x to the power 5 is not 6x cubed, it's 5 times x to the power 4. Okay, so do you see the problem? These are obviously equal to each other, and yet attempting to apply this mistake I'm talking about gives us the wrong answer, right? So, do not do that. We'll see if this works. So, do not do that.